In today's video, we are going to be finding the rate of change of linear functions. So we're going to be looking at three different scenarios and determining the rate of change from a equation, from a graph, and from a table. And there's different strategies involved in each of them. With an equation, it's pretty simple. It is the coefficient, the number next to the variable x. Okay, so for this first one here, all right, my rate of change is 7. So my m is going to equal 7. Okay, usually they use the letter m to signify rate of change. And then the next one, again, what's next to x? Right here, it is 1/2 is next to x. So in this scenario, your m is 1/2. This one, it's hard to tell, but there is a number out in front of x, and it's an invisible 1. So your m is 1. This one, you have to distribute first. You could say it's 3x, but it has to be simplified first. So if I multiply 2 times 3x, that is 6x. And then 2 times 7, that's 14. Okay, now my slope is 6. Okay, and slope is another term for rate of change. That's why I said that. And then the next one, what's next to x is negative 0.4. So my slope here, my rate of change is negative 0.4. And then the last one, in front, there's an invisible 1, but you also have to be careful because you are taking into consideration the negative sign as well. So in this one, your m is negative 1. So pretty simple how to find the rate of change of an equation. As long as it's simplified, it's the coefficient next to the variable x. Now let's look at some graphs. So we have two graphs here. And as you heard me say before, another word for rate of change is slope. So m is also, it's called the rate. It's also called the slope. And the reason why it's called the slope is because you're measuring the steepness of these lines. So in order to do that, we have to pick 2 points, and they should be going up at a constant rate. So there's a point. So we look at our graph here, and we make sure we pick out points that lie nicely at the intersection of the grid lines. For example, this point right here lies neatly on the grid line. So I'm going to put a dot there. Okay, this doesn't. Don't include that. Don't include this. This one is a little bit off too, but this one lies nicely on there as well. Okay, again, no, no, no. Here's the next one. No, no, no. Here's the last one. So these should be going up at a constant rate. Now, the thing I tell my students to help them remember what the rate of a graph is, it's called rise over run. Okay. And what do I mean by that is I take the point to the left, right? And I count how many boxes it goes up. So this goes up 3. So it's rising 3. Yeah. Fix that 3. There we go. And then it's running 4 boxes. So this one goes up 3 over 4. Up 3 over 4. So it's a constant rate of change. It's going up 3 over 4, up 3 over 4, up 3 over 4. So that is my slope. That is my rate. That is my m in this case. So in this case, it's 3 divided by 4, and I don't need to simplify that. It is simplified all the way. This one, Yeah, there's a point right here, right? So I'm going to put a point there. Make it thicker. Then go here, right? That's another one. This, no, no, no. Here, no, no. Here, no, no. There, okay. You'll see the common trend with this. This is going down 3, right 1. Oh, didn't want a straight line. Down 3, right 1. Down 3, right 1. Down 3, right 1. Down 3, right 1. Okay. So this is -3 over 1, which simplifies to just -3. Now, you don't always have to pick the points that are next to each other. For example, if I picked this one and this one, right? Pick these two. This I would go up 1, 2, 3, 4, 5, 6, right? This goes up 6, and then it goes right 1, 2, 3, 4, 5, 6, 7, 8. Okay. If you notice, 6 over 8, that reduces to 3 over 4. So you just have to make sure you reduce at the end. Same thing with this one. I could have went down 6, right 2, right? Down 6, right 2 also simplifies to -3. So it doesn't always have to be points that are right next to each other, but you just have to make sure you simplify at the end. All right, let's take a look at a couple more graphs. Let's look over here. There we go. Now we have 2 lines on this one. I'm going to look at the horizontal line first. So this one starts here, doesn't go up or down, it just keeps going right. So it just keeps going right, 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 right. So there is no, it doesn't go up or down. So your M is 0 and the run is over 1. 0 over 1 is just 0. So whenever you have a horizontal line, that is 0. Okay, now this one, a little different. Pick something anywhere on here. This could either go up or down. I'm just going to go up. It's going up, 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 right? So this slope is going, it's rising 1 and running 0. But you cannot divide by 0. I'll even prove it to you in the calculator. That is a math law. You cannot divide by 0. So when this is the case, when you have a vertical line, the slope is undefined. All right, so whenever you have a horizontal line, it's 0. Vertical line, it's undefined. Now let's take a look at some tables. All right, we've got 2 different tables here. Again, with the tables, you're just finding the rise over run of the tables. So the rise is the y values. So you're seeing how much the y values go up. So this goes up 2, right? This goes up 2. And this goes up 2. The run is right 1, right 1, right 1. So this is your rise, and this is your run. So your slope, your M, your rate is 2 over 1, which is just 2. Now this one, it's going right 1, right 1, right 1, right 1. This one's going up 5, up 5, up 5, up 5. So now a common mistake a lot of people make with the horizontal tables is they'll say, oh, the slope is 1 over 5, but it's the rise over run. So the y values go on top. So in this one, it is your M is 5 over 1, which is just 5. So you got to be careful when you have a horizontal table. Let's look at another one. 2 more. Okay, same thing here. This one goes down 9 over 3. Down 9 over 3. And it doesn't always have to go the same common trend. As long as the ratio is the same, you might see some problems where the ratios, it doesn't go down the same amount all the time because you have to look at the ratios equivalent to it. So this one is, my m is, it's an ugly m, I'm going to redraw it, is negative 9 over 3, which reduces and simplifies to just negative 3. Now with this one, we got some decimals here. I just ignore the decimals. Just ignore them. It's okay to skip over points. So this 3 to 2 goes down 1. Negative 2 to 0 goes right 2. Same thing here. Down 1, right 2. So your slope is negative 1 over 2, which is actually negative 0.5. This is going down 0.5. Right? This would be the same thing as this. All right, I would accept both answers. All right, so again, I would avoid using the decimals. You can skip over them. And again, they don't always have to be a constant. Like you could have a scenario where instead of going down 9 over 3, you could go down 6 over 2, right? Another point on this grid, if we went down 6, it would be negative 29, and then over 2 would be 8, right? So that would go down 6. I'm sorry, not 8. It would be 9. So this would go down 6 over 2, right? Negative 6 over 2 also simplifies to negative 3. So it doesn't always have to go in that constant same difference. But as long as you divide them and they're the same at the end, that's what that matters. All right, so that's it for today's video. Thank you for watching. And always remember, whether you're solving for X or Y, always give math a try.